Good morning. Good afternoon. That was a very cheesy Thursday song that we started off with. All right, let's go ahead and take our page of notes. No calculators today, please. All right. These are going to go with the notes 7.2 today. So video note 7.2 is where these are going to connect with. Hopefully we can help make these easier to understand. Here we go. We're going to talk about some special right triangles. And the first one is called 30, 60, 90. And it's called the 30, 60, 90 triangle because it is a triangle with angle measures
30, 60, 90.
Yeah. 30 degrees, 60 degrees, and 90 degrees. And the really special thing about this triangle in particular is that the sides are always in the same pattern. And here is the pattern. It's almost like a shortcut using this pattern. So draw yourself a right triangle. We're going to mark this one as the 30-degree angle and this one is the 60-degree angle. Now, bless you. The small side, which is the one that's directly across from the smallest angle, that is always going to be kind of our landmark. Okay? So it's going to be the one that everything else depends on. The hypotenuse is going to be 2 times whatever that number is. And the side across from the 60 is going to be that number times the square root of 3. At this time, please use the right-hand side, this little empty space here, to write down whatever you need to remember, whatever you need to write down, so that this makes sense to you. Remember that the small side is always directly opposite the small angle. The hypotenuse is always 2 times that. And the 60-degree angle is the one with the square root of 3. Take a moment to update your notes right now. Give me thumbs up when you're ready. Thank you. Thank you. Thank you. Thank you. Thank you. Did you? You ready to go? Oh, okay, thank you. Thank you. Let's do 2 more. Thank you. There's 1. Thank you. All right, I'm just going to scoot it up just a little bit. And we have our next special right triangle, which is the 45, 45, 90. Similar to the one before, that it's a triangle, and it has the angle measures that match its name. So its angle measures are 45 degrees, 45 degrees, and 90 degrees. And again, these sides are always in the same pattern. Here we go. So draw yourself another right triangle. Here's your 90-degree angle. And here are your 45s. Now, what was our recall symbol here?
The recycle.
The recycle, thank you. Now back in, the threes, I think it was, unit threes, we had something called the Isosceles triangle theorem, or something. Isosceles triangle theorem. Which basically said that if I had a triangle and I had two angles that were congruent to each other, the sides opposite those angles were also congruent to each other, and that made this an isosceles triangle. Okay? So we're going to use that same idea here to say that these two sides are congruent. And then this becomes our landmark. Thank you. Just trying to remember.
X marks the spot.
X does mark the spot, which means this one is also X. Up here, the hypotenuse is X times the square root of 2. So take a moment right now, and in your empty space off to the right of your diagram, write down whatever it is that you need to know to remember how this works. Give me a thumbs up when you're ready. Thank you. Thank you. Thank you, thank you. Thank you, thank you. Thank you. Thank you. Thank you. Let's do 2 more. Thank you. There's 1. Thank you. There's 2. I'm going to slide it up just a little bit. There we go. All right. And so the question you might be asking yourself is, okay, great, but why does this work? Right? Why does it work? Okay, let's take a look at it and see why. Let's take a look at it and see why. So draw yourself another right triangle. Make it a 90-degree triangle. And make this one a 30, 60, 90, please. This side is going to be 2. Make this side 4. And then we don't know what this other missing side is. And so the directions for us becomes find the missing side length. It's 1?
That's what it says that you want to use.
Okay. Well, let's go figure it out. What kind of triangle do we have? It's a right, because we have a right angle in there, which means that we're allowed to use the Pythagorean Theorem in order to check relationships. We know it's a right triangle, so we know that the relationship is going to be the equals. We know that the large side, the one across from the right angle, is always the hypotenuse, so C must be 4. And now we need to figure out which one is which. Which one do you want to be A and which one do you want to be B?
I want 2 to be A. 2.
2 to be A, okay. It honestly didn't matter which choice you picked. Okay, so now we have an equation with only one thing unknown, so we can solve this for B. So here we go. This is 4. This is 16. Subtract 4 from both sides leaves me with 12. And then we go, okay, well, I need to get rid of the square. So to get rid of squares, I take the square root. And I'm left with B equals the square root of 12. Don't use your calculators. Don't. Several days ago, not several weeks ago now, I think, when we were first learning distance formula, we took a moment to talk about how to simplify radicals. Do you remember that? Yes? Some do, some don't. That's okay. So this is a recall moment when we were talking about distance. We were talking about how to simplify the radical. And I want to add the hourglass to it, which says that this is a skill that is going to carry directly into next year for you. So I'd like to take a moment to remind you how to do that simplification. So I'm going to zoom in right here. So here's the reminder on how we do this. Simplify the radical. The first step to simplify the radical is to ask yourself what numbers multiply to give me 12. What are the factors of 12? Give me some. Factor pairs. 6 and 2. Which other ones?
59.
Huh?
59.
59. Factors of 12.
Oh, no, I thought you were asking for numbers. Oh, factors of 12, 6. 2 and 6.
We've got 2 and 6.
6 and 4.
3 and 4.
6 and 2.
6 and 2 technically the same thing.
Oh, okay.
Because multiplication doesn't matter the order. It's commutative.
12 and 1.
12 and 1.
3 and 4.
3 and 4. All right. The next question to ask yourself here is, which pair, which set contains a gentlemen, ladies, thank you. The next question to ask yourself is, which set contains a perfect square? A perfect square is a number that you get from squaring a whole number. So if I look at 6, what numbers multiply together to give me 6? 2 and 3. Are those the same number? No, they're different. 2 is different from 3, so 6 is not a perfect square. What about 2? 2 and 1. Same number? No. So these can't be it. What about 3? 3 and 1, not a perfect square. What about 4? 1 and 4, but 2 and 2. So this is a perfect square, which means this is the pair that we can use to replace 12. So I'm going to replace. So b equals the square root of 4 times 3. Radicals like this have a property that when it's all multiplication, you can break the radical at the multiplication and write it as 2 different radicals. What's the square root of 4? I don't need to write the multiplication symbol. It's implied. Look at the pattern. Look at this compared to the pattern from, I can't get it on the screen, at the very top. This side here ended up being 2 square roots of 3. Look at your pattern from the top of the page. Do you see it? You see it? The very top of your page on the 30, 60, 90. You see it? So now when you're faced with 30, 60, 90 triangle, you don't have to do the Pythagorean Theorem. You can just use the shortcut. It feels like cheating. But it's not. It's using your resources. Let's do an example straight from your workbook. So here's an example. It's coming to you directly from page 124, which is one of your new items that is needing to be done. And this is question number 11. Question number 11 looks like this. Gives you some sort of square, box-looking thing. Has a line in the middle through it. Shh. Hey. This angle's a right angle. It says these two are congruent to each other and they are x. And this line here in the middle is 8 square roots of 2. Which of your two special triangles does this one look like? The 30, 60, 90 or the 45, 45, 45? 45, 45, 90, I meant. That one?
I'll say 45, 45, 90.
You're right. This one is a 45, 45, 90 because you've got a right angle and the legs congruent to each other. That makes these two angles congruent to each other. Because it's a 45, 45, 90, the hypotenuse is x square roots of 2, where x is one of the leg values. According to this figure, we are given that the hypotenuse is 8 square roots of 2. So what must x be? Say it one more time.
8.
Yep. That's it. And these questions, these special right triangles, they're so easy and they are such a trick for so many things that these are actually really big questions on those college entrance exams that some of you are thinking about taking soon. And so if you're really good at picking apart the pattern for these, you can answer those questions really fast. And you can get really good scores with very little amount of work. Any questions on how special right triangles work? It's just a little pattern. Can you see it still? A little bit? Okay. Let me go ahead and bring it up to pause it, and then I'll zoom it back in for you in just a second. All right. Thank you very much.